Okay, girls, so let's start with taking notes about our matter and mixtures theory part 2. If you haven't read this document, please stop now. Don't watch this video. I want you to read it first, highlight it, and then watch this video. This document is in Google Classroom in the post of the 7th of October in a Word document, okay? Good. Let's get started. So, atoms is the first thing that they explain. So they talk about matter that is made up of extremely small particles called atoms. So far, every time that we talk about matter, we say that everything around us is made up of extremely small particles. And we always talk about particles, particles, particles. But those particles are actually called atoms. So that's word you need to start get familiar with that word, atoms, okay? You are going to see this in year 8 in more detail, okay? But for now, I just want you to understand a little bit. I want to explain a little bit what these atoms are. So this is a model, a representation of what an atom is. You don't need to learn or memorize all this. I just want to explain it to you so you understand it. And what you need to know is that this is a representation of an atom. A real atom doesn't look like this. It's a little bit more complex than is it. It's actually something that is fascinating and that you will learn later on if you continue to do VCE chemistry and physics, because it's very, very exciting um, how atoms actually work. But for the meantime, this is a good representation that help us to understand how atoms work. And basically, each element of the periodic table um, has a unique atom with a unique amount of matter. So I want to show you what is the matter in here. So the matter of an atom is made up of mainly the nucleus that is here in the center, and that has protons and neutrons. You don't have to memorize all these words. I'm just trying to explain what it means. Protons are charged positive, and neutrons are neutral, and that's this nucleus is basically the amount of matter, the amount of mass that each atom has. And as I said before, each element of the periodic table has a different mass. So each element in the periodic table will have a different atom that has different amount of neutrons and protons, and it's determined. Each atom will say, okay, it has, let's say, 6. So we know that's certain element, and that's unique for that one, and all atoms of that element is going to be the same. And these little particles that are orbiting around the nucleus, you can see it looks a little bit like a solar system, are called electrons. And the electrons are negative charge. And we already know this because we have done electromagnetism. We know that negative charges and positive charges attract. So that's why these negative charges are orbiting around these positive charges, okay? And they're just going around. So the second concept that you need to learn is about what is an element. And I already talked about what is an element just before when I talk about atoms. So an element is a substance that is made up of all the same atoms. Exactly what I just said, okay? So each element is only has one specific type of atoms. Or you can also say, if the atom is the same to another atom, it means that they belong to the same element. They are all in the periodic table, and they are pure substances. And we say that they are pure substances because they contain only one element, okay? Some examples are, for example, oxygen and gold. So oxygen, I already have spoken about this one. We use this formula, and where we're saying oxygen, if you look in your periodic table, if you want to be curious, you see that the symbol for oxygen is O, and this little 2 means that it has 2 atoms. of oxygen. So the oxygen that we breathe is actually made up of two little particles that actually are called atoms, and that's what it means. Okay, gold, if you look in your periodic table, if you want to be curious, the symbol for gold is AU, a small u. So here in this diagram that we have here, that I think is the same diagram that you have in your um, notes, it's the diagram of a molecule. You don't have to know that word either, but a molecule of oxygen, which basically says molecule means more than two atoms. So it has more than two atoms. It doesn't mean that, but it means that it's not only one atom, it has more than two. So we have here more than one or and two atoms of oxygen, and this whole thing is a molecule. Molecule is right like this, molecule of oxygen. Okay, so an element is a pure substance, and they are all in the periodic table, and they have only one type of atom. Good. Let's go to the next one. Compound. So a compound is made of more than one element. So it's when we combine actually two elements from the periodic table. And this is very important, girls. These ones are chemically combined. They're not only physically combined, they are actually chemically combined. So the structure actually changes. And that's very, very important for you to know. In a set ratio. So this is a mathematical word. And ratio, what do we mean by ratio? We mean that they have a certain proportion. So I'm going to explain this because this is also very important. And I'm going to give it with another example. If I'm going to make lemonade, and don't laugh, but this is important, girl. If I'm going to make lemonade, for example, and I'm going to make only one glass of lemonade, yes? So I need half of glass of lemon juice, yes? Lemon juice. And I need the rest water, and I need one spoon of sugar, let's say. Okay, and this is only for one glass, okay? If I'm going to make a whole liter of lemonade, this is only for one glass, and if I'm going to make a whole liter of glass, then these proportions to only one little glass, I have to keep the same proportion. So I have to multiply whatever it is. I'm not going to do it here. I'm not going to do the whole maths, but I just wanted to explain it. So let's say I know that in a liter, there are 4 glasses. So I know that there are 4 glasses here. That means that I have to multiply this one by 4. So I know that I need 2 glasses of lemon juice. Okay, girls, last video stopped recording, so got cut off. So I'm going to continue in what I was explaining before about what we meant by set ratio. Hold on one second because, okay, good. So what I was saying before, I was giving the example of the lemonade, right? So I was saying, imagine that I'm going to do it here. Is this pen working? Is it? Let's see. No, it's not working. Oh, yes, it is. Okay, so I was giving the example of the lemonade. So let's say that my original, I'm going to call it original lemonade. So it was in my first glass. Agree? So lemonade. Okay. So as we said, we have 1/2 of a glass of lemonade. And then I think we said, I don't remember, but let's say 1 spoon of sugar and the rest water. Agree? So if I'm going to convert this into a whole liter, so I have one original lemonade, like my original lemonade for only one glass, for only one little glass. And now if I have a bigger glass, and it's not going to be a bigger, but it's 1 liter of lemonade. Okay, and I know that in this big glass, I have 4 little glasses filled in. So that big liter is equal so to 4 glasses. So it's like preparing this 4 times. And because it's preparing like this 4 times, I know that what I have to do is to multiply this one times 4 and this one times 4 in order to prepare this full liter. So if I do that, I know that I'm going to have 2 glasses of lemonade and 4 spoons of sugar. Okay? Um, so this is what we mean by a ratio, something that is proportional. That means that we will find like the same ingredients in only one or in many. Always is going to have the same proportion of ingredients. That's what we mean by a set ratio. So taking that into account, so a compound, it is more than one element, it's chemically combined in a set ratio, so I have a set proportion of ingredients and can be described using a chemical formula. It's also considered a pure substance because it has the same chemical structure, a molecule. So before we saw the example and we saw that, for example, when I have oxygen, okay, we said we have only one element, okay? In this case, I will have 2 elements, but it also has the same chemical structure. The molecule that we're going to look as an example is, for example, water, where I have 2 hydrogens and 1 oxygen. And that's what we mean. This is in one molecule of water. And we say that it has the same ratio because it means that the ingredients for one molecule is 2 hydrogens and 1 oxygen. If I need 5 molecules, then it will be 10 hydrogens and 5 oxygens because it always have to have the same proportion. The examples are water, and that's the example that I was giving you before. HO2, that's the chemical formula that we use, and sodium chloride, that the formula, and this one is a very popular as well, is this is sodium and this is chloride. If you look in your periodic table, you will see these ingredients, and that's the formula for sodium chloride, and that's the formula of common salt. So that's what we know as salt. Okay, and if you see an image, you see that we have 2 atoms of hydrogen for 1 of oxygen. So this is the molecule of water because it's 2 hydrogens, the 2 orange ones, and 1 oxygen. Therefore, this one is the formula for water. Fantastic. Okay, what is a mixture? So a mixture, it's a group of atoms that are physically combined but not chemically combined, okay? And these are the types of mixtures that we have been talking about in the whole term that we have doing matters and mixtures. They can occur in different ratios. So, for example, if you think about if you're going to do chocolate milk, not chocolate milk, like I maybe I like it very sweet, so I use, I don't know, 4 spoons of chocolate of Milo into my glass of milk. And let's say, I don't know, Alana doesn't like it as sweet, so she only has 1 spoon of Milo in her whole glass of milk. Both of them are chocolate milk, so they can occur in different ratios, okay? Therefore, can't be described with a chemical formula because they occur in different ratios. we can't use what we used before here, these formulas that we have here. These formulas cannot be used because in a mixture there are different ratios. Okay, fantastic. I'm going to stop this video here and I'm going to continue in another one. Oh, sorry, this is one last thing that I wanted to say. Mixtures are not pure substances because they cannot be described in a chemical formula and they don't occur in different ratios. Okay, fantastic. Thank you. Okay, girls, so in our previous video, we were talking about the mixture, what a mixture is, and we were talking that it's a group of atoms that are physically combined but not chemical combined, and we said that those are the examples that we have been using so far in our unit of matter and mixtures. They can occur in different ratios and they can be described with a so therefore they be described with a chemical formula, and they are not pure substances. So examples can be salty water and coffee. So if we look at a diagram, this is a diagram of salty water. So if we look up here, you can see that we have different ratios of all the elements that are here and all the molecules that are here. Salty water. So if we look here, you can identify this one. We have here a molecule of water. You can see here we have a molecule of water. And you can see that here we have sodium and chloride and chloride and chloride and sodium and sodium. You can see that there are different combinations and everything is mixed together. So you see that it looks different, like when we have a pure systems, like for example, only water here, that looks very set, and combined here, it's everything is like all mixed together, and that's a mixture different to a compound. Okay, so I thought about giving you like a diagram of to define what do you have, if you have an element, if you have a compound, or if you have a mixture. So the first question that you need to ask is how many elements. Notice that I'm not asking how many atoms, I'm asking how many elements do you have. If you only have, you can have one or more than one. If you only have one, then it is an element, is the only option. If you only have one type of element, which means that it's only one element of the periodic table, then it is an element. If you have more than one, then you have two options, but you have to ask a question before. Is it chemically combined in a set ratio? If it has a set ratio, if the answer is yes, then it's a compound. If the answer is no, then it's a mixture. If you have questions about how this diagram works, please let me know. Okay, in your notes, when they talk about type of mixtures, they talk about, again, solution, colloid, and suspension. I am not going to go into details of these ones because you have plenty of notes about these ones, but the only thing that you are missing in your notes, and that's why I decided to include it here, is to say that the solution doesn't reflect light. So if you put a flashlight through a solution, through a colloid, and through a suspension, only colloids and suspensions are going to reflect light. I'm not going to go into much detail of why this happens, because for understanding why this happens, we have to understand more light, the phenomenon of light. And to do that, we have to go into further years of science about waves and how light behaves. But the main thing that you need to know is, like in colloids and suspensions, the molecules are very big. And because they are very big, it allows the light to reflect. In solution, because the molecules are very, very small, it doesn't allow the light to reflect. That's like the basic explanation that I can give you with the knowledge that you have so far. Perfect. Now, we're going to talk about separating mixtures. So if we start talking about separating mixtures, with flocculation, we already have done notes about flocculation, and we talk about examples of aluminum potassium sulfate and carbonate solution. So that's already done, so I'm not going to do that. Centrifuging. So I don't know how you say this. Centrifuging, I think, or jing. I have to find out how you say that correctly. But the basic idea is that this separates particles by spinning very, very fast. So I hope that we finish the theory part quickly so we can do a little bit of an experiment of how to do this. But the idea is that if you spin something very, very fast, think about a salad. I don't know if you have a salad mixer. Like when you wash the lettuce and you put it like in a salad mixture, and you turn it around very, very quickly, and you go, the salad goes spinning around, then the water goes out and that dries the lettuce so the lettuce can continue to be crispy. That's an example of centrifuging. So it separates particles by spinning it there very, very fast. There's an example of Billy T and damper. That's the example that I want to do with you girls in an experiment, in a prac. Hopefully we can do that. And also blood. So when you take a sample of blood to the laboratory to split it up into the parts of blood, they take it into a machine that spins very quickly and it separates blood. I'm going to put a video of an example of how this works so you can see. Look at it. Okay, another way that you can separate mixtures is by filtration. Filtration can separate particles based on their size. They will work for suspensions and colloids. And a good example is what we already did in our part 4 of cleaning dirty water when we did this prep after using the flocculant. Remember that when we put the chemicals, then we left them for a while and then we let it to settle, and then we used the filtration paper and we were able to filtrate the water and we were able to obtain clean water. So that's a very good example here that you already have. Evaporation is another way, another method that you can separate a mixture. So a solute can be removed from a solution by evaporation. The solvent, this looks very complicated here, but all these words you already know. So basically, if you have salty water, so the solute, which is the salt, can be removed from the solution, which is the water, by evaporating the solvent, by evaporating the water. So the solution is the salty water. So if you evaporate the water, you will obtain the salt. Example, evaporating the water from salted water. Perfect. Crystallization, when only crystals of the original solute remain. So again, the same example of salty water works here. After evaporating the water of salted water, you will obtain crystals of salt at the bottom of your pan. Maybe you have seen this in some when you're cooking, or if you have helped your parents cooking, you will have seen this. Fantastic, girls. I think with this we finish this video. No, we still have to go more, but I'm going to stop here and then I will continue in the next video. Thanks for watching. The other process that we're going to see today is distillation. So distillation is the process of using evaporation and condensation to purify a liquid. So remember that evaporation is when you have a liquid and it goes into a different state of matter, that is gas. So that's the process of evaporation. And condensation is the opposite, is when we have a gas and it goes into liquid. So if you remember, we used this process in one of the demos we did in class when we had water with an orange liquid and we were able to obtain clear water after using distillation. So the example for this one is the demo that we did in class. Chromatography. I really hope that we have time to do this prac because it's going to be a lot of fun. So chromatography is when we separate the different compounds of a mixture of an ink or dye. So what happens in chromatography is that we have the different compounds have different strengths of attraction to the solvent and to the paper. So the solvent being a liquid and a paper as a special paper that is used for chromatography. I'm going to post a video because it's very difficult to understand how this works without doing a prac and without having a visual. And because I'm not sure if we're going to have time to do the prac, I'm going to post a video so you will be able to see it. So the ink will be absorbed by the paper at different rates, which means at different velocities. And that will separate the different components of the ink or the dye. The different parts of the mixtures can be separated. Okay, and with this we finish all what we have covered with theory part 2. So as always, girls, if you have any questions or if you didn't understand anything of these videos, please ask me while we are in class, okay? Or if you have questions later on, just send me an email and I'll answer your questions. Thank you, girls. Bye.